Hi, Richard.
Yeah, speaking.
Hi, Richard. It's Tom Copping.
Hi, Tom. How are you doing?
Yeah, I'm absolutely fine, thanks. I want to start with a bit of your background and then the company background. So, where you've come from in the industry, what relation or not relation that it has been with lightning detection. Yeah, could you expand on that?
Okay, so from my background, I'm an engineer in electronics, and I worked for 25 years in the telecommunications area with companies like Siemens, like Nokia. Corient was the last company where I was for 5 years, the managing director and head of sales for Europe, Middle East, and Africa. So in this time, we had some smaller touching points with lightning issues, but not too much. I remember a case where we had problems with fiber optic transmission, which were on the high voltage lines. And during thunderstorm season, this was in Russia, we had problems. And after some time, we found out that this is due to lightning strikes. But except of this, there was not too much connection to this lightning topic. But I was keen on doing something else, and this now is with Nowcast, where I'm the managing director since the 1st of February this year. It fits a lot to my expectations on a job in terms of having control over a mid-sized company. It meets the weather topics where I'm personally interested in, as I'm a private pilot, glider pilot. So I'm very interested in weather, and now we have a lot of customers of the aviation sector, which is interesting for me. And last but not least, it's a company with a huge potential. For me, this looks like even a bit of a hidden champion, if I may say so. I can bring the sales to a next level, and it started already to show the impacts, and we are growing a lot in this year. So we will already in the first year of my time grow by 50%. We have won a lot of new cases, so there is a lot of potential in this company.
Yeah, it sounds like it's going really well. I mean, in terms of Nowcast itself, how long has the company been in action?
The company was founded in 2002 by Professor Dr. Hans-Dieter Beetz, who is the father of the company. He was professor at the MIT in Massachusetts and then mainly on the Ludwig Maximilians University in Munich. And he was doing a lot of research there around the topic of lightning detection networks. As he was working with the German Meteorological Service, they're in a research project, and he found out that all the lightning detection networks which were available at this point in time were not good, not satisfying his requirements. And so during his university days, he developed a new system, a better system, and it was that good that they said, hey, well, we can sell it to the market. This is not only a research project. We can do it in a more professional way and then sell it to the global market. And so the company started in 2002 and very, very soon became the global champion in lightning detection.
Yeah, I mean, in terms of the professor, was he always wanting to assist with the issues of lightning detection, or was it just something that he stumbled upon whilst he was doing his research?
Now, this was his topic. This was one of not the only one, but one of the topics he was very interested and working with. Where, in my understanding, he stumbled about was the fact that there is no system on the market to detect the lightning strikes with a good quality. This is where he stumbled about it. But the lightning topic itself is very close to his heart, and he is one of the really well-known experts, I even say, of the very, very few gurus about lightning.
Yeah, it sounds very much like that. I mean, because I obviously know Daniel. So is Daniel the professor's son? Is he? Right.
Yes,
Okay.
yes.
So the company is also partly a family business as well.
It used to be a family business. It was grown as a family business, but then a few years ago sold to the Ubimed group. Ubimed was a customer. Ubimed is providing weather services, mainly for business customers, very well recognized as a technology leader in this space, and they were a satisfied customer of Nowcast. And then they started to invest in the company many years ago, and a few years ago then the company was completely sold to Ubimed. But the professor is still around, so he's helping me still as a consultant. He is 77 in the meantime, but still helping me as a consultant if needed.
Right. Okay. So there's still a lot of academic prowess behind in the background if needed.
Yes.
Right. Okay.
A lot. And due to the personal network of Professor Beetz, there is a strong link to the academic community. So we are still working a lot with academic organizations. We are supporting doctoral theses and a lot of academic works that are still close ties to this academic world.
Yeah, well, I mean, I think, I'm sure you'd agree that the best companies in the industry are those that keep abreast of all the research that's going on and hopefully take a part in the research themselves.
Of course, this gives us insights in the latest status of research, of new ideas, brings new ideas, and it also brought in several cases the proof that we really have a leading system, as there are several research projects where our system was compared with the competition, or our system was compared with different technologies like these high frequency networks, which have a very high accuracy but work only in a small area. And this research projects have shown that we are by far having the best quality when it comes to efficiency, when it comes to accuracy. So this is very helpful for us to work closely together with this research and academic community.
Yeah, I mean, I think we've touched on that, and I think that's a unique aspect to what you guys are doing, which, as you're saying, puts you head and shoulders above the rest, as it were.
Yeah.
In terms of the problems surrounding lightning detection, obviously we talked about it for the inception of Nowcast in 2002 after the professor's research paper. But, obviously there are a lot of problems surrounding lightning detection as it stands at the moment, and that's all around the world. But I think that there are two parts to this. There's the technological aspect, and then there is the aspect of sort of the geographical areas. So within the developing world versus the developed world, for instance, and the problems of lightning detection in those areas. So I suppose if we could start on the technological problems, and then we'll move on to the other ones.
Of course. I mean, you said there is a lot of challenges around the lightning detection. I mean, one of the main challenges is that also the weak strokes has to be measured. As only this gives you a really comprehensive prediction about the quality and the development of a thunderstorm. There's also the intra-cloud strokes, and they are often very weak strokes. They are important to assess the strength of a storm, to derive a lot of information out of it. But also, as cloud-to-crowd strokes, even the very weak ones, can cause severe damages. And this, of course, is a technology issue, a challenge. And Nowcast has a unique, ingenious antenna design, a really unique one, a highly efficient measurement technology and filters, which have been optimized over the years. And with this, we have an outstanding sensitivity and detection accuracy, so that we can detect also the weak strokes, less than 3 kiloampere, which are really considered as weak strokes, and also this with a high location accuracy. So the average is 70 meters, which is in this area a really, really high efficiency and accuracy. And this is appreciated by many, many customers all over the world. Is it in Germany, the weather service? Is it insurance companies like Allianz, the army, so the Federal Armed Forces? And also around the world, many weather services, airports, energy companies, organizers of open air events, etc., wind park operators are customers, highly satisfied customers, and this all over the world, all over Europe, Australia, North America, Asia, Latin America, so basically all over the world. And one topic when you say that the challenge is the weak lightning strikes, which is also very important, is to get some information about the altitude of the cloud strikes. And we are the only one who have there a solution. It's a patented solution. It's a field-proven solution to have a real three-dimensional picture of the clouds, of the lightning strikes, of the thunderstorm activities. And this is very important, for instance, for air traffic controllers. This is important for weather services to derive information about the strength of a thunderstorm. So we are really ahead of the competition there in terms of three-dimensional representation of the thunderstorm.
So, what I'm trying to understand, obviously for our listeners as well, is going to be about the take-up of the technology. Some highly qualified meteorologists in Germany or in the US will be able to probably understand this straight away. But if you're trying to push this into certain areas that you're not in already, of South America or in Africa, Pacific Islands and the like, which all have a lot of thunderstorms and lightning throughout the year, is the technology easily usable? Is it very user friendly for people, or is there a lot of training that needs to happen before they can fully understand what's going on?
No, not at all. And thank you for this question. Actually, the graphical representation, the linear view, the software of our solution is very easy to use. It's to a large extent self-explanatory, but still provides enough information and details for the real experts, for the research people. But in general, it's extremely easy to use, and it's also in countries more on the developing world. It's highly appreciated and can easily be used. For instance, just recently, we had a big project in Nepal. This was a World Bank project, as Nepal has many problems due to severe weather there. There's a lot of issues with flooding, with landslip, many fatalities due to lightning strikes. Therefore, they now have installed advanced weather warning systems to provide better warnings to the regional organizations there in the country. And actually, the lightning detection network, which was an important piece of this new system, was installed by far as the first one with the best performance also in terms of the rollout. So the network covering all of Nepal was implemented in a pretty short time period. Training of the staff there was not an issue at all. So it worked from the scratch in a highly satisfactory way.
Yeah, it sounds like you've, as we say in England, you've got it down to a T, which means you've got it very, very precise, and it seems to be very successful. I mean, going into this idea of success, I'm sure there's a plethora of different stories and case studies that you have on the success stories of Nowcast being involved in terms of National Hydrometeorological Services, and that's where we really want to go today, because most of our listeners are going to be from National Hydrometeorological Services in the developing world. So do you have a couple of examples of or case studies of your efforts in certain areas of the developing world where you've been tasked with perhaps installing a national network or a part network, some of the problems that were faced at the beginning and then how you solved them.
Yeah, one example I explained already was in Nepal. We have installed networks in many areas in the world, and the benefit for the country, for the people, for the organizations there is very, very easy. It's an easy business case to gain by the savings. So we have installed networks on many airports around the world. And just recently, an airport in an area in Europe where there is not too much thunderstorm activities, they made a calculation that due to our system, they could reduce the time for the handling stop by almost 90 minutes. And closing an airport for 90 minutes, or in the other way around, saving 90 minutes of closure, this is a lot of money. This is a lot of saving, in addition to protecting the people, that there is no danger that something happens with the ground handling staff. So there are airports all around the country. Then we have just installed a network in Malaysia, for instance, in a part of Malaysia, in Sarawak, for the energy company, for this organization. They use it to protect their people so that nobody is working on the high voltage lines or whatsoever. When the thunderstorm is coming, they also use it to detect problems in the network. If they have a problem in the power distribution and they correlate it with the lightning information, they know, okay, this was a problem caused by a lightning strike. I do not need to worry. I do not need to send the staff out. It will resume immediately. Or if there was a problem, I know exactly where to send the staff. We work with wind farms all over the world, in Latin America, in Colombia, for instance, also there with power companies. So this system is used in all level of customer cases and standards of the countries.
So it's a multi-industry solution.
Yes, definitely it is.
You talked about wind farms, civil aviation, also national Met services.
Definitely it is, and the application is in different industries, but this is not saying that it only can sold to the industries themselves. If it is sold to the weather service, the weather service then is in the position to help those kind of industry, those kind of companies in increasing the safety of the staff, in saving money, in having operational benefits.
Yeah, I mean, I think that the World Bank actually released a video recently which basically said that everything starts with hydromet, and a lot of people have not taken on board just how important hydromet is. But obviously, within the last couple of years, with issues of climate change and global warming, we as an industry are facing a major issue with that, which is a great benefit in terms of boosting the growth of the industry, and obviously technology to make sure that we solve the issues. So, yeah, I think you're very right in saying that it really starts with hydromet, because hydromet is so intrinsically involved with all of these different industries.
Now, I think we touched the most important point, and this is exactly the topic, that it brings so much benefit to a wide range of users. No matter if this is provided through the weather service or directly, it is so helpful to many areas. And in each of these cases, the business case is very easy to be calculated, as the investment for such a system or for the data is relatively small compared to the savings, to the benefit what you gain from this high quality data. As I said, if you can reduce the ground handling stop of an airport, if an air traffic control can make better decisions for the routings of the planes, if an energy company saves time in allocating or in finding out where the issue is, if a wind farm does some preemptive maintenance for the windmills, so checking the blades, if there was a thunderstorm, a strike close by, in order to avoid much bigger damages. If you can save lives, if you can increase the efficiency of the operations, the business case is very easy. So the investment, the effort is extremely small compared to the savings gainings.
Yeah, it seems like it's not only a multi-industry, but in terms of the horizontal scope of sectors, but also vertically in terms of the many different attributes that it has beyond just being a system to Nowcast Lightning. It's got the commercial aspects. It's got the saving of lives aspects. It's got many different things along the way, which, well, it seems like it's a win-win, if you like, for every stakeholder.
Definitely it is. You perfectly have summarized this.
Thank you very much, Richard. Is there anything that you'd like to say to our audience before we finish the conversation?
No, thank you, Tom. I think we have discussed the major points. It really was a pleasure talking to you. Thank you.
Brilliant. Cheers now.